One of the biggest causes for radiated emissions failures is largely due to poorly terminated cable shields. For example, this HDMI cable, it's impossible without taking it apart to confirm how well the cable shield is terminated to the connector back shell here. And it's really important that this back shell be connected to a product's shielded enclosure in a very short path. In fact, HDMI cables are notorious for causing radiated emissions failures. So I'd like to demonstrate why proper cable termination on the shield is so important. So I have our pulse generator. This is a harmonic comb generator putting out harmonics every 10 megahertz. And we're going to use it to drive a coax cable that is terminated with a 50 ohm load. We'll be sensing any outside cable shield currents using the current probe connected to the spectrum analyzer. This is a Siglent SSA 3032X spectrum analyzer. We're looking from 10 megahertz to 300 megahertz. And right now we're seeing very little current flowing on the outside of the shield. Normally we would expect all the currents to flow on the inside of the shield, not the outside. Now, because this cable is not perfectly shielded, we will be getting a little bit of harmonics showing up here. So notice that I have a barrel connector connecting the load to the coax. We're going to replace that with this large loop of wire that's going to simulate a long pigtail in the shield circuitry. So I'm going to reinstall the 50 ohm load, and we'll connect this up to the cable and see what happens. Now, as you can observe, the harmonic content has jumped up 20 to 30 dB across a range of about 100 megahertz to 300 megahertz. And so this is exactly what happens when you use a long lead between the cable shield and where it terminates. This large unsymmetric geometry that we've just added into the cable shield circuit is causing common mode currents to flow back through the outside of the shield back to the source. And we're picking that up through the current probe here. So let me replace the large pigtail here with a simulated geometrically equal ground or shield connection. Notice that I've used two PC board mount connectors, and they are connected in 4 places in a balanced geometry, and that makes it important. This also simulates a multiple connection of cable shield terminations. So let's try this now. Again, we have short pigtails, but there's more of them, and it's a balanced type configuration. And you can see that we're back to what we had basically with the barrel connector. Everything is fairly low here. We're getting a few responses. This large one here is probably an FM station at around 90 megahertz. So you can ignore that. But you can see the small responses, and it's roughly equivalent to a solid barrel connector. So this just demonstrates the importance of short connections between the cable shields and wherever it terminates.